So, a pebble is dropped into a deep water well. So I drew a picture of this well here. Water's at the bottom. Shh. And the sound of the splash as the pebble reaches the bottom is heard 3 seconds later. How deep is the well? And it says neglect the time required for the sound to travel back up. So basically, the 3 seconds is the time it takes for the pebble to reach the water. And that's a pretty long fall. If you're falling for 3 full seconds, 1 1,000, 2 1,000, 3 1,000. That's a pretty far fall, you know. Okay, so the time of the fall, t equals 3 seconds. And there's more information we know here. So the first thing you're doing, you're setting up your diagram, labeling all the information that you know. Even though the problem doesn't explicitly say it, there's 2 more things that we know. What's one of them?
The initial velocity is 0 meters per second.
The initial velocity, V initial, is 0 meter per second. Now look, it says right here, a pebble is dropped. If you drop something, what's the starting velocity? If you take something and just drop it, as opposed to throw it, what's the initial velocity? 0. Okay, what's the other thing we know?
Acceleration is 9.8.
The acceleration. So as this pebble falls towards the water, the acceleration is equal to gravity, which is equal to negative 9.8 meter per second squared. All right, so what do we not know? The stuff that's missing? Well, down here, right before the stone hits the water, there's a final velocity, which we don't know. And then the other thing that we don't know is the displacement. So from up here down to the water, let's call that x. That's the displacement of the pebble. So the question's asking for the depth of the well. How deep is the well? So how could we solve for the depth of the well? Or do you have a question?
Oh, I just have a question. So you know how this one doesn't say displacement? If a problem does give you a displacement, but there's just say like the displacement is.
Yeah, or sometimes they might call it distance. You see, distance and displacement are only different if the object changes direction.
Okay.
You know, but if an object goes in a straight line without turning to the left or turning to the right, if an object moves in a straight line, the distance and the displacement are the same. So how are we going to find the depth of the well? The depth of the well is the same as what? The distance that the stone falls, right? However far this stone falls, that is the depth of the well, okay? And our answer is going to come out negative. This x, when we solve for it, it's going to come out negative because why? It's going down, right? So our sign convention is down is negative, up is positive, okay? All right, so here are the motion equations. Which equation can we use to solve for the depth of the well?
The third, well, you can solve for the third one and then use the final velocity to
Yep. So you're saying you could start with this equation, solve for v final. So once you know v final, then you could use another kinematic. Then you could go to the second one and find x. But hey, could we avoid that and just do it in one step?
Yes.
Yeah. If you look at the first equation right here, the first equation, what's v initial for the stone? 0. So this part goes away. V initial goes away. So we're left with x equals 1/2 at squared. So that's going to be 1/2 negative 9.8. And then the time is 3 seconds. So the answer comes out negative, and that's going to be negative 44.1. So how deep is the well? You would just say that the well is what? 44 meters deep.
Or 44.1 meters deep.
44.1 meters deep. The only reason our answer came out negative is because why?
Because gravity.
The stone is going down, right?
Plus gravity.
That's why it came out negative.
And plus it's gravity also, right?
Well, it's negative because of gravity. The stone is accelerating downward.